Belt transfer points, we tend to use wheel jets, which are hollow cone sprays. So when the dust is airborne from one conveyor to another conveyor, the wheel jets suppress them because it's more fine atomised droplets. It's hollow cones, so you're not using a full cone where you're actually going to add a lot of water where you might create mud. So wheel jets are always the most important nozzles for belt transfer points.
Well, there's a few methods for suppressing dust at belt transfer points. If you can have a little bit more moisture on your product, we can wet the top as it's moving along before the transfer point with some spray bars, maybe just some flat V-jets. As the product's falling, we can then wet the underside to suppress some dust. Some belts might have hooded transfer points, and if they do, we can then use some fine hydraulic atomisers or air atomisers, but really fine misting sprays, like below 20 micron. But we can only really do that in a hood, otherwise the wind will just blow it all away. At enclosed belt transfer points, the best solution is a fine mist spray. We can use some whirl jets or even go finer with some hydraulic atomisers. Being that it's enclosed, we can create the mist inside. You won't have the effect of wind blowing the fine mist away.
Mud buildup is caused by droplets that are actually too big, actually bigger than dust itself. So what we have to do is we have to match the dust particle size with the droplet size. You get big droplet size, you'll create mud. And that's why it's important with dust application that the last thing we do is create mud.
If you're finding mud around chutes, it's generally coming from the fines ore. What happens is, because there's a high moisture content in the ore, it starts to stick to the back wear plates, and as it sticks to that back wear plates and with the heat, it builds up and builds up to the point it starts to collect in the ore, and then they get basically issues with the ore being displaced in the wrong areas, which causes problem on tracking on conveyors and ore ending up shooting out the side of the chute. So it's got to be basically stopped and cleaned so they can be rectified and back to normal process.
V-jets are great for adding moisture to conveyors that actually prevent dust from being airborne further down the line. So they play an important part and actually don't provide or don't supply the nozzle at the end to do all the work. So dust prevention is just as important as dust suppression.
Well, the V-jet's a fairly standard nozzle, but it's a flat spray pattern. Comes in brass or stainless. It's typically used for applications where you need to wet product, the coal on top of a conveyor or underneath the conveyor.
Generally with bulk ore conditioning, what they're trying to do is they're adding extra moisture to the ore as it's travelling along the conveyors. The best nozzle to use is a V-jet nozzle because it will basically cover the ore, and because it's a flat spray, it penetrates the ore a lot further than if you used a full cone nozzle.
The nozzles most suitable for conveyor applications are either V-jets, full jets or hollow cone nozzles, depending on the application you're using it with on that conveyor belt.
Again, anything with conveyors, you generally stick with the V-jets because they give that deeper penetration into the ore, giving a better coverage and stop pooling on the top and causing conveyor back carry issues. Generally on the screen house, they use dust extraction systems. So because they're using dust extraction systems, you can't add water because it blocks the screens as well. So the option they usually have is they put a fogging spray around the bottom side of the conveyor to suppress the dust from expanding outwards, so it actually gets pushed down to a ground level and it can actually be washed away.
The armoured face conveyor is just below the canopy. So we try with the same nozzle that's in the canopy to wet the coal on the armoured face conveyor, and that solves that problem with the armoured face conveyor. Yes.